All right, welcome back. Like I said before, we are going to be doing some story problems. So I have pre-written the story problems, which means that you are going to need to pause the video to get this story problem written. Please pause the video and get it all the way written and then push play. Oh, I should also mention that you should get this new side set up. It says dividing by decimals story problems. And then I have written this story problem about Braylon and Rachel. So go ahead and push pause on the video until you get your journal looking like this. All right, so in this story problem, we have two people, Braylon and Rachel. They're hiking 15 miles today. After every 0.5 mile or half mile, they will stop and rest. How many times will they rest during the hike? So we have two bits of information. We have their total, they're going 15 miles, and they're going to stop and rest. The stop and rest means division, and they're going to do that every 0.5 miles. So we're going to take their total divided by the distance that they stop. Okay, let's write that off to the side here. We take their total divided by distance. We'll say each distance stopped. That's a little confusing. Like when I think about that, that's a little bit confusing to word it like that. But let me show you what that means. It means I take their total, which is 15, and I divide it by the distance, each distance that they stopped is 0.5. They're going to stop every 0.5 mile. So you divide that by 0.5 or 0.5. Now, when you're looking at this, you have to decide where the decimal is. The decimal is in the divisor, which means we follow the steps of getting rid of the decimal. So I move the decimal one place to the right here, which is timesing it by. So I moved it one time, which really means that I timesed it by 10 to the first power. Remember, that's how that works. So if I did this to the divisor, I have to do it as well to the dividend. So if I take 15 and I times it by 10 to the first power, what happens? Well, what is 10 to the first power? It's just 10. So it means that I'm going to be adding 1 0 to the end of 15, making it 150. So my new problem is 5 is the divisor and 150 is the dividend. What this is saying is this answer, 150 divided by 5, is the same thing as 15 divided by 0.5. Same thing. Okay, 5 goes into 15 3 times. Bring down the 0. Five goes into 0 times. And I know it would be 0 at the end. So my answer is 30. The question is, how many times will they rest during the hike? They will rest 30 times. They will rest 30 times. See how that worked? Not too bad. All right, let's slide our journal down. And again, you're going to see a new story problem, which you'll need to pause your journal, pause the video, and get this new story problem written. Ready? Pause. Okay, you should have had the whole thing written now. Now you can resume it. It says a cookie cutter shark is 0.4 meter long, and a thresher shark is 6 meters long. Those seem important. Let's circle those. How many times as long as the cookie cutter shark is the thresher shark? This phrase, how many times as long as, a lot of people think because it says the word times that it's going to be multiplication. But really, it's not multiplication because I'm comparing the cookie cutter shark, the 6, to the thresher shark, the 0.4. So in order to figure out the difference or how many times is long, I'm actually going to be doing division here. So even though it says how many times, this is a division problem. It's called a comparison division, a comparative division problem. We're just going to say comparison, though. That will help you remember. Okay, so I take the thresher shark, because that's what we're asking about. I take the thresher shark, which is 6, and I divide it by the cookie cutter shark to find how many times is long. Okay, well, this has a decimal in the divisor. So I multiply it by, or I move it once, if that's confusing to you, move it once to the right to get it to be 4. And what that really was doing was timesing it by 10 to the first power. If I times the divisor by 10 to the first power, then I have to also times the dividend by 10 to the first power. So go ahead and do that. What is 6 times 10 to the first power? Well, you have to know what 10 to the first power is, which is just 10. So what is 6 times 10? It's 60. If you didn't know that, you would just go, okay, well, there's no decimal, so I'll put it at the end, and then I'm going to move it one place, which means I would need a 0. In order to move that decimal one place, it becomes 60. So my new problem says 60 divided by 4. Does 4 go into 6? Yes. So you place the 1 above the 6 because it goes in there one time, and you subtract 4. And you get 2, and you bring down the 0. And then 4 goes into 25 times, so you put a 5 in the quotient, and you subtract 20 because that is 4 times 5, and you get 0 as a difference. That's your proof. And the answer is 15. So how many times as long as the cookie cutter shark is the thresher shark? So we'll say the cookie cutter shark is 15 times as long. Sorry. The thresher shark is 15 times as long as the cookie cutter, because the thresher is bigger. So you're going to say the thresher shark is 15 times bigger. So the thresher shark is 15 times as long as, I'm going to use their exact phrase, as long as the cookie cutter shark. The thresher shark is 15 times as long as the cookie cutter shark. That is my final answer, and I'll turn my journal page. You're going to see a new story problem, and you'll need to again push pause on the video and get the new story problem written. Welcome back. You should have written this story problem. The story problem says, at a large wedding, the cakes were cut into hundredths, so each piece was 0.01, or that's a hundredth, right? That number is a hundredth. I'm going to read it again. At a large wedding, the cakes were cut into hundredths, so each piece was 1/100th of a whole cake. That makes sense. If there were 12 cakes, how many pieces were there? So we have the total amount by the size. So this is a division problem where you're going to divide the total amount, which was cakes, divided by the size. Total divided by the size. So I have 12, and I'm dividing it by 0.01. This may seem really easy, and it is going to be pretty easy, but you still have to show the work. So I spot the decimal, which is step number 1. Step 2 is to get rid of the decimal. So I need to move it 2 places. I always just write a little 2. And then I write, oh yeah, because I moved it 2 places, it was like timesing by 10 to the second power. And because I got rid of it, that 0.01 is now just 1 as the divisor. Now I take the dividend, and whatever I did to the divisor, I have to do to the dividend. So I also have to times 12 by 10 to the second power. Where's the decimal at in the number 12? It's at the end. So that means I need to move it 2 places over, or I can fly in 2 zeros. Right? Because now it would be over there at the end. So because I did this to the divisor, I have to do it to the dividend, and I just changed the 12 to now be 1,200. And this is really easy. Whenever you're dividing by 1, 1's going to go into each number exactly that amount of time. So, right? If I have 1,200 pieces and everybody gets 1, how many people can I serve? That's the idea. 1 goes into 1 time. 1 goes in, and you can keep doing this division if you want. 1 goes into 2 times. And then you're going to get all of these. 1 goes into 0 times. 1 goes into 0 times. So 1,200 divided by 1 is 1,200. Kind of silly to do all that work for that, but that is how it works. So if there were 12 cakes, how many pieces were there? There were 1,200 pieces. Some people might be thinking, well, don't I need to put the decimal back in? No. Because we did the decimal in the divisor, we then have to do it to the dividend. If we didn't do it to the dividend, we would have to move the decimal more at the end of the quotient. But we already did it, so we don't need to take care of that. All right, you guessed it, slide your journal down. This will be the last story problem we write, so you'll need to push pause on your video. Okay, you should have this written now. If you don't, push pause. A millimeter is, 1,000th. That's how you say that number. A millimeter is 0.001, or a millimeter is 1,000th of a meter. How many millimeters are there in 7 meters? So I take the total and I divide by the size. This is a total divide by the size again. So my total is 7. That's my total. My size is 0.01. So 7 divided by 0.001. I think I said that incorrectly just a minute ago. 0.001 divided by 7 divided by 0.001. Okay. Well, I have to get rid of this decimal. You always have to get rid of it if it's in the divisor. So you're going to move it 3 times because that gives it a whole number. Put a little 3. You moved it 3 times, which really was timesing by 10 to the third. And when I times it by 10 to the third, I make it just be a whole number, which is 1. Okay, if I times the divisor by 10 to the third, I also have to times the dividend by 10 to the third. How do you take 7 and times it by 10 to the third? You add 3 zeros to the end of it, because 10 to the third is 1,000, and 7 times 1,000 is 7,000. Notice how when I add those zeros in here, I shade them in so that I remember I added them and they were not part of my original problem. Helps me remember that. You could also show the loop-de-loops if you want, because remember the decimal would be here at the end of 7. Oh look, we're dividing by 1 again. What was the strategy we learned up above? If you take 7,000 and divide it by 1, it's just going to be 7,000. So the answer is, how many millimeters are there in 7 meters? There are 7,000 millimeters. in 7 meters. Okay, those were 4 really good story problems. Now I want you to find your homework and remembering for 5.7. And I want you to take a really good look at the homework side, the first 4 problems. Some girls are going hiking, we have cookie cutter shark, we have wedding cakes, we have millimeters. Those look really familiar. Will you please take your crayon and shade in numbers 1, 2, 3, and 4. You can find the answer to those in your journal, so you can just write the answers along the lines. But when you get to number 5, you're going to have to do that one on your own. So let's take number 5 and set it up and then move along. Number 5 is talking about saving for a new bicycle helmet, and he saves $36. For how many days has Paco been saving? So you take the total that he saved divided by the amount each day. So this is going to be a total divided by amount per day. Please write this on your assignment, especially since I helped you with the first 4. So write the total divided by the amount per day. So I'm just going to do all the work up here because you have plenty of space. I take 36 divided by, I'm going to leave all the dollar signs off, 0.75. And you are going to have to solve that problem. You're going to have to use your journal for help with the steps because we've done a lot of these together. On 6 through 13, you're going to have to do this as well. I would use a separate piece of paper because you're going to probably be rewriting a lot of them. So I want you to write this, separate piece of paper. I would like you to work these out on a separate piece of paper. Even if you're like, no, I can fit them on here. I don't care. I want it on a separate piece of paper. In fact, if you don't put these problems on a separate piece of paper, you're going to owe me a couple stamps, probably 3. So please follow directions. Okay, on the remembering side, you need to complete all of them. Number 1, I really want you to read it carefully because it says, what is the difference? This is basic stuff. The difference means subtraction. This is the button man. You have to line the decimals up. Number 2, if someone withdraws an amount, it is also subtraction, which means you need the button man again. Button man, you're going to need the button man on both numbers 1 and 2. You have to stack the decimals up in their right places. And 3 through 8 is all about solving multiplication with zeros and with decimals. So let's just take a quick look at number 5. You need a decimal box because there are decimals. A 2 would go in there. You've got a 0 in front, so it's a runt. You've got a 0 at the end. You drop it down. It's your friend. And now I'm doing 32 times 7. It's pretty easy. I'm taking a piece of 70. It can't be 2,000. That's because of this decimal box. 22.40. Circle that in this red violet or fuchsia color. Thank you so much. Good luck to you. You don't have to do the stretch or thinking. Thanks for hanging in there. Make sure to also check Think Central if you finish your homework and remembering. See you next time.